In this video, let us solve this question. So we have n raised to power n is equal to 9. And here, to solve for the value of n. So n is the unknown, what to solve for. To do this, solution. So right here, you will pick a number, and that same number, you will raise it to that particular number, and the value must equal to 9. So let's say we try 1. 1 to the power of 1 is equal to 1, and this is not equal to 9, obviously. Now, if you try 2 raised to power 2, this is equal to 4, and it is not equal to 9. If you try 3 raised to power 3, this is equal to 27, and this is not equal to 9. So, but then if you look in between 2 and 3, that gave us 4 and 27. The number 9 is in between 2 and 3. You see, 4 is less than 9, but 27 is what's greater than 9. So that means that the range of values is in between 2 and 3. Now, to exactly get the value that will give us 9, there is a much more easier way for us to solve this. Simply apply this method. So we have n raised to power n equals to 9. First, we're going to introduce natural logarithm. So this becomes ln raised to power n is equal to ln 9. So from here, applying this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. So applying this rule right here, power n, then come to this side, this becomes n times ln n equals, we have ln 9. So with this, what we have is n times ln n equals to ln 9. At this junction, for us to simplify this further, we're going to introduce the Lambert W function. So we call it the Lambert W function. Okay. Now, this Lambert W function can be used if you have an expression in this form, a times e raised to power a. If you introduce the Lambert W function to this, what you will get is a. Okay. Also, if you have, let's say, a phone, right? A phone times e raised to the power of the phone. Okay. If you apply the Lambert W function to this w, what you will get is a phone. Okay. So, making use of this Lambert W function, we are going to manipulate this expression to resemble this form. Now, to do so, we're going to introduce e, right, to this. Now look at it. If you have e raised to power ln x, this is equal to x. Why? Because if we cancel ln, x stands alone. So in replace of n right here, we can say e raised to power ln n is equal to n, because if we cancel ln, n stands alone. So in replace of n, we can bring in e raised to power ln n. This becomes e raised to power ln n times ln n, right, is all equal to ln 9. So with this, okay, we are then going to look at this form right here. Notice that e is in the second place. So move this e to stay in the second place. This becomes ln n times e raised to power ln n equals ln 9. So at this junction, we are then going to apply the Lambert W function. So w into brackets ln n times e raised to power ln n is equal to w times ln 9. Now, once we apply the Lambert W function to this right here, what you're going to have, the value will be equal to ln n is equal to w times ln 9. So with this, the next thing is for us to remove this ln from here to solve for n. And to do so, simply introduce e. So e raised to power ln n is equal to e raised to power w times ln 9. So with this, if we cancel ln, the value of n is equal to e raised to power w times ln 9. And with this, we have gotten the value of n. But then, if you are wondering, okay, why is the number why is the value not in numerical form? So to get the value in numerical form, simply press in your calculator the value of n equals, press E. Now instead of pressing W, you press product log, then multiplied by lane 9. Now if you do so, what you will get as the value of n will be equal to 2.4510, okay, in 4 decimal places, 2.4510. Now this means that if you raise 2.4510 to 2.4510, you will approximately get the value to equal 9. Okay, so with this, you have gotten the value of n. Okay, so at this junction, please don't forget to like this video and also subscribe to this channel. Please do well to subscribe. Thank you very much. See you in the next video. Bye.